Chapter 8, Part 7. Let's review what quadratics are and take a look at a way to solve quadratic equations. Remember that a quadratic equation is an equation with the highest exponent of 2. For example, y equals 2x squared plus 3x plus 1. The highest exponent on the variable is a 2. That's what makes it quadratic. It has to have something. It has to have the x to the second power, nothing higher than that. In standard form, a quadratic is ax squared plus bx plus c equals 0, so all your terms on one side set equal to 0. So if we take our example 2x squared plus 3x plus 1, we set that equal to 0, that's considered standard form. Factored form is where we use the method we've been practicing this chapter to factor it and figure out what binomials we must have multiplied to get that trinomial. So we fill in our first term, we fill in our last term. The product of these two will equal the product of the unknown diagonal. So 2x squared times 1 is 2x squared, and that's what we fill in as the product on our diamond problem. The sum is the middle term, so we fill that in. I need two numbers that multiply to 2 but add to 3. It's 2 and 1, so I want 2x and 1x. I fill those in, and we're going to factor out every row and every column. So 2x and 1 are both divisible by 1. 2x squared and 1x both have an x. 2x and 2x squared are both divisible by 2x. 1 and 1x are both divisible by 1. So factored form would be 2x plus 1 times x plus 1 equals 0. Now let's think about how we can solve quadratic equations using factoring. If 3x equals 0, what would x equal? Well, we'll divide each side by 3, and we see that x equals 0. In order to multiply to 0, one of your items has to be 0. So if x minus 4 equals 0, what does x equal? Well, we'll add the 4 to both sides, and we'll see that x would have to equal 4. So that 4 take away 4 gives you 0. Next, we're asked to list an example of any two numbers that multiply to 0. So I want you to write your own two down. So think of two numbers that multiply to 0. I'm going to go with 5 and 0. Could have done negative 25 times 0. Negative 387 times 0. Basically, anything times 0 would equal 0. If you're going to multiply to 0, one of the factors has to be 0. It's the only way to multiply to 0. So using that idea, if x minus 2 times the quantity x minus 1 equals 0, what could x equal? Well, x could equal 2, because then we'd have 2 minus 2 times 2 minus 1, which would equal 0 times 1, which equals 0. Or x could equal 1, because then we'd have 1 minus 2 times 1 minus 1, which would be negative 1 times 0, or 0. So we get that by taking each individual factor and setting it equal to 0. X minus 2 could equal 0, and so we add the 2, and we see that x could equal 2. Or x minus 1 could equal 0, we add the 1 and see that x could equal 1. So there's two different values that could make that equation equal to 0. 2, which makes the first quantity 0, or 1, which makes the second quantity 0. One of them has to be equal to 0 in order to multiply to 0. So if we had x minus 7, the quantity, times the quantity x plus 5 equals 0, we can split it by something known as the zero product property. The idea that if something times something is 0, one of them has to be equal to 0. So we set each individual factor equal to 0. So x minus 7 equals 0, or x plus 5 equals 0. And then we solve. And then we see that x could equal 7, or x could equal negative 5. So this is method number 1 of solving quadratics via factoring in the zero product property. Step 1 is to make sure the quadratic is in standard form. So make sure the quadratic equation is in standard form. Which means all of your terms on one side, and it's set equal to 0. Step 2 is to factor the quadratic. So remember GCF first. Then use diamond in a box. Step 3 is to set each factor individually equal to 0. And then step 4 is to solve each equation for x. So when we solve a quadratic, we find the solutions for x. There are several ways they can refer to these solutions. They're sometimes known as the roots of the equation, the zeros of the equation, or the x-intercepts of the equation. Roots, zeros, and x-intercepts all mean the same thing. They refer to the fact that we're finding the x values that produce an output of 0. We find x by setting y equal to 0, so those are the x-intercepts, or the points on the x-axis. There are 3 possibilities when you solve a quadratic equation. There could be 2 solutions, so your parabola could cross the x-axis twice, like this, or like this. When you factor, you would have 2 distinct factors, and you would set each factor equal to 0, and solve to find 2 distinct values. Or there could only be one solution, so the parabola could just be sitting on the x-axis like this. Or like this. So when we factor, we'd only get one distinct factor, so we'd have something like x minus 2 quantity squared. So it's the same factor twice. So when you set that equal to 0 and solve, you'll only get one solution. Or there can be 0 solutions. You could have a parabola that just does not touch the x-axis at all. And so these would not be factorable. So when we solve linear equations, you either get one solution, infinitely many, or no solution. But with quadratics, you're either going to get 2 solutions, one solution, or no solutions at all. So the zero product property is what allows us to solve quadratics via factoring. When the product of 2 or more numbers is 0, one of those numbers must be 0. This is known as the zero product property. If the 2 numbers are represented by a and b, this property can be written as follows. If a times b equals 0, then a equals 0 or b equals 0. For example, if 2x minus 3 times x plus 5 equals 0, then 2x minus 3 equals 0 or x plus 5 equals 0. When we solve, we would get x equals 3 halves when we add the 3 and divide by 2, or x equals negative 5. This property helps you to solve quadratic equations when the equation can be written as a product of factors. So let's take a look at a complete example of how to do this. You'll need to write this example into your notes. So if we are given x squared plus 6x plus 8 as our quadratic, first thing we do is set it equal to 0. Then we need to factor it. I check for a GCF, but they don't all have an x, and the largest number they're all divisible by is 1. So we fill in our first term and our last term. The product of these two is going to equal the product of the unknown diagonal, so it's 8x squared, and I put that as the product of my diamond. The sum is this middle term, which is 6x, so I need two numbers that multiply to 8 but add to 6. We want 2x and 4x. So factoring this row, 2x and 8 are both divisible by 2. X squared and 4x are both divisible by x. 2x and x squared both divisible by x. 8 and 4x both divisible by 4. So that in factored form I have x plus 2 times x plus 4 equals 0. And now by this zero product property I can set each of these factors equal to 0 and solve. So I get my two solutions. X could equal -2 or x could equal -4. Those are the two x-intercepts of that parabola. They're the two roots or two zeros. The solutions to the quadratic equation. So that's what we're going to do in this section, is practice solving quadratics via factoring. It's why we've been practicing factoring and learned how to do it in the first place.